All right, this is section 3.3 and 11.4, talking about the finishing up the probability unit here, talking about conditional probabilities. Okay, we're going to, in terms of objectives this section, we're going to determine if two events are mutually exclusive. We're going to discuss what this means. This is going to be a very important part of this section. And we're going to also use the addition rule to find probability of two events. Last section we used multiplication rule. This time we'll use the addition rule. Okay, so talking about being mutually exclusive and mutually exclusive events. To be mutually exclusive, what that means is, that means that two events that cannot occur at the same time. Okay? Two things that you cannot be at the same time. So you're not going to be more than one thing at a time. For example, you cannot flip a coin once and get a heads and a tails at the same time. If you flip the coin, you're either going to get a heads or you're going to get a tails. You can't get both at the same time. Okay? Those are things that are mutually exclusive. You see in parentheses here, the word disjoint. They're not related to each other. As you look at the picture down here on the bottom, this is an example of a Venn diagram here of mutually exclusive. So here's the probability of A, here's the probability of B. They're completely separate. They have no relationship. They don't share anything at all. They're separate from each other in order to figure out that probability. Okay? Not mutually exclusive is when two events that occur at the same time. Okay? For example, you can be a boy and a football player at the same time. Okay? You can be in both categories at the same time. That is not mutually exclusive. Okay? Again, as you look at the Venn diagram down here, in this case, A would be boys, B would be football players, and this middle area would be a boy and a football player at the same time. Okay. Another example of not mutually exclusive. Okay. Another example of not mutually exclusive would be this. If you were a queen, okay, a queen and a heart. Can you be a queen and a heart at the same time? Well, sure. You have the queen of hearts. Okay? So this is not mutually exclusive. This over here would be the queens. This would be the hearts. And the one thing that would overlap would be the queen of hearts right here. Okay? It's both a queen and a heart at the same time. That's not mutually exclusive. Okay? That's going to tie into how we're going to find these probabilities of things where the things overlap. Okay? All right, now let's take a look at being able to decipher what's mutually exclusive and what's not. Okay, that's what this first part here is. Decide if the events are mutually exclusive or not. So, you roll a 3 on a die, then you roll a 4 on a die. Can you be a 3 and a 4 at the same time? Can you roll a 3 and a 4 at the same time? Is essentially the question that you're asking yourself. Okay? And in this case, no, you cannot roll a 3 and a 4 at the same time. So this is what we call mutually exclusive. Okay? You cannot roll a 3 and a 4 at the same time. Letter B. You randomly select a male student. Then you randomly select a nursing major. So again, the question that you're asking yourself here, can you be a male student and a nursing major at the same time? Yes, you can. You can be a male nursing major. So in this case, it is not mutually exclusive. Okay? The reason you're not mutually exclusive is because you can be a male nursing major. So you're overlapping into two areas. Okay? Letter C, randomly selecting a king, then randomly selecting a heart. Okay, again the question, can you be a king and a heart at the same time? Yes, you can. So this is not mutually exclusive. Because you can be a king and a heart at the same time. King of hearts. Okay? So this is what you're going to have to do to start here. You're going to have to start and be able to determine, is it mutually exclusive, is it not mutually exclusive? Okay? So now, how do we find these probabilities? That's the question. Well, on these probabilities, you're going to use what we call the addition rule. Okay? The addition rule. Or you'll notice you see the word or here. Now, with the multiplication rule, you saw the word and. With the addition rule, you're going to see the word or. Okay? So we have to decide, first of all, the very first thing we got to do is decide, is it mutually exclusive or not mutually exclusive? Okay? So, if it's not mutually exclusive, and we want to find the probability of A or B, okay? We're going to find the probability of A, add it to the probability of B. And remember, if it's not mutually exclusive, that means that there's something here that it's getting counted for twice. And what we have to do is we have to subtract the part that's counted for twice out of it. Okay? Because you can't count for something twice. You can only count for something one time. It can't be part of two groups. Okay? So anytime for not mutually exclusive events, you're going to have to be able to subtract whatever it is that they both have in the groups. Okay? For mutually exclusive events, this is just very easy. We want to find the probability of A or B. They're separated. They're not sharing anything. We just find the probability of A and the probability of B, and then you just add them together. There's nothing to subtract. Okay, because the two groups are separated. Okay, so now let's take a look at some examples here. Okay, using the addition rule. It says you select a card from a standard deck. Find the probability that the card is a 4 or it's an ace. Okay, again, the first thing you have to ask, can you be a 4 and an ace at the same time? No, you cannot. So this is an example of a problem that is mutually exclusive. They are completely separate. Okay, so whenever I find this, I need to find the probability that you get a 4, add it to the probability that you get an ace. So the probability that you get a 4, there are 4 4s in the deck. There are 52 total cards. The probability that you get an ace, there are 4 aces in the deck. There are 52 total cards. And now I'm going to add these two guys together. Now remember, when you add fractions, your denominators do not change. You add the top numbers, the numerator. So 4 and 4 is 8. 52 stay the same. And when I go ahead and calculate this, 8 divided by 52 is 0.15. And again, what will happen is they'll change these most of the time. Sometimes you'll leave them as fractions, sometimes you'll leave them as decimals. Right now, I'm going to calculate them as a decimal rounded to the nearest hundredth. Okay, let's take a look here at letter E now. You roll a die. Find the probability of rolling a number less than 3 or rolling an odd number. Okay, so a lot of times when I look at problems like this, what I like to do is list out what the possibilities are. Okay, so the probability of me rolling less than 3. What is less than 3 on a number die? Okay, well, I've got a 1, I've got a 2, I've got a 1 and a 2. Okay, that's the only two numbers that are less than 3. All right, now, as I look at this, what's the probability of me rolling an odd number? What are the options there if I roll an odd? Well, I've got 1, 3, and 5. Okay. Now, as you look at these two lists for the probabilities, do any of these probabilities overlap, or are any of these numbers written down more than once? Well, you notice that you see the number 1 is in both lists. So in this case, this is not mutually exclusive. Because you can be a number less than 3 and be an odd number at the same time. Okay? So, I need the probability that I'm going to be less than 3 plus the probability that I'm going to be odd. And I'm going to subtract that from the probability that whatever I have, however many I have in both groups. So the probability of me rolling less than a 3, I have 2 numbers out of 6 total. Okay? I'm going to add that to the probability of me rolling an odd number. That's 3 out of 6 total. And I'm going to subtract however many there are that are double counted for. In this case, I counted for 1 twice, so I'm only going to subtract. There's only one number that's counted twice, so I'm going to subtract 1/6 from it. So now I get 2/6 plus 3/6, which is 5/6, minus 1/6, which is 4/6, and this rounded to the nearest hundredth is 0.67. Okay. So again, how you determine the number we subtract is however many times the number was counted for multiple times. Okay. So let's take a look at letter F. It says you select a card from a standard deck. Find the probability that the card is a king or a spade. Question. First, can you be a king and a spade at the same time? Sure you can. So this, in this case, is not mutually exclusive. So on the not mutually exclusive, I got to figure out what is counted for twice. Well, so I'm going to take the probability that you're a king plus the probability that you're a spade minus the probability that you're a king and a spade together. So what card is it that's going to be a king and a spade? Well, that's the king of spades. That's the only one. Okay, so the probability that it is a king is 4 out of 52. Plus the probability that it is a spade, there's 13 spades out of the 52. Now, as you look at this 4 out of 52 right here has the king of spades in this group. This 13 out of 52 has the king of spades in that group as well. So I've got to I can't count for it twice. I got to take that extra king of spades and get it out of there. Subtract it out. So now 4 and 13 is 17. Minus 1 is 16 out of 52. And if I make that a decimal, that's 0.31. Okay? So in this section, we learned about the addition rule. We learned about how to find whether it's mutually exclusive or not. Okay? Make sure you complete the WSQ for this section once you get finished with this. And this is section 3.3 and 11.4.